Hey everyone, this video is about the unit circle and basic trigonometry. The idea is that I don't want you to have to memorize the unit circle, but you can use some basic principles to derive some information and then use a couple techniques to calculate the values on the unit circle. Our first step is going to be trying to fill in the angles on the unit circle that are multiples of pi over 6. For now we're going to ignore the 45-degree angles like the pi over 4 and the 3 pi over 4, etc. We'll do those in the next slide. So starting at 0, we're going to start adding, we're going to count by pi over 6's, and we're going to count this way. So we're going to start by adding pi over 6, which gives us pi over 6, which is our 30 degrees. Add another pi over 6, you get 2 pi over 6, which reduces to pi over 3. Add pi over 6, you get 3 pi over 6, which is pi over 2. 4 pi over 6, 2 pi over 3, 5 pi over 6, 6 pi over 6, 7, 8, 9, etc. Right? Some of these reduce to values that you normally see on the unit circle. But essentially, if you're trying to figure out where is let's say 11 pi over 6, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6. If you want something like 4 pi over 3, you realize that if you double it, you'll get 8 pi over 6, so we need 8 pi over 6's. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 pi over 6. So using this, you can fill in all the multiples of pi over 6, or the over 3's, on the unit circle. Similarly, we can count by pi over 4's to fill in all the 45-degree angles. Starting at 0, you have pi over 4, 2 pi over 4, which by the way is pi over 2, 3 pi over 4, 4 pi over 4, which reduces to pi, 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, 7 pi over 4, and then back to 8 pi over 4, which is the same thing as 2 pi. So using those two techniques, you can figure out where any of the angles that you're being asked about are on the unit circle. And if you wanted to just recreate the unit circle, that's one way you could come up with all those radians pretty quickly. The next thing is how to figure out where these numbers on the unit circle come from, the root 3 over 2's and the 1/2's, etc. What we're going to do is take one of these points, drop a line straight down to the axis, and this creates a right triangle, because all these values are based on right triangles. This is our 90-degree angle. This is 30 degrees because this is pi over 6, and that makes this 60 degrees. So this creates what's called a 30, 60, 90 triangle. Similarly, if we drop a line down up here, this is also a 30, 60, 90 triangle here. This time this side is 60 and this one's 30. There are special properties with 30, 60, 90 triangles that help you figure out the sides of those triangles. And then lastly, for the 45-degree angle, if we drop down a line there, this time we have a 45, or this one's 45, a 45, 45, 90 triangle. That also has some special properties about the side lengths. So I'll show you the properties for the 30, 60, 90 triangle. You can Google the one for the 45, 45, 90. This really just explains where the numbers come from. I don't think you need to derive this every time you try to figure out values on the unit circle. But the properties here, if you have a 30, 60, 90 triangle, there is a ratio of the side lengths. This side, the side opposite 30 degrees, if that is 1, then the opposite side, the side opposite the 90 degree would be twice as much, so it's 2. And then the side opposite the 60-degree angle will be root 3 times this side, which in this case will just be root 3. So 1, 2, square root of 3, those are the ratios of the side lengths for any 30, 60, 90 triangle. If you take an example, let's say that you have a 30, 60, 90 triangle and the side opposite the 30-degree angles has a 5-inch or something side length. Well, you know that this other side over here with the 2 has to be 2 times as much. So this would have to be a 10-inch side length. And the side opposite the 60 degree would have to be root 3 times as much, which we'll just call 5 root 3 inches. So that's kind of how you use this basic fact about triangles. If you know it's 30, 60, 90, and if you know one of the values, one of the side lengths that is, you can figure out the other two using these ratios. Now what we actually have on our unit circle, since it's a unit circle, the radius, which are all the hypotenuse of the triangles, the radius will always be 1. So instead of a 2 there, we have a 1. Notice 1 is half of 2, which means the other side, the side opposite the 30 that has the 1, it's going to be half of 1, which is 1/2. And the root 3 side is going to be half of that, which will be root 3 over 2. Right, so we're basically taking this ratio, the 1, 2 square root of 3, And because the 2 side is 1, we have to cut everything in half. Half of 2 is 1, half of 1 is 1/2, half of root 3 is root 3 over 2. That's where these numbers come from. The 1/2s and the root 3 over 2s that you see all over the unit circle, that's where these values are from. And similarly, if you look at the 45, 45, 90 case, that's where you get the root 2 over 2s. Now, instead of having to derive using the 30, 60, 90 rules and everything, the 1/2, the root 2 over 2, and the root 3 over 2s, I would just think about how big each of those numbers are and scale them. So for example, 1/2 is the smallest, root 2 over 2 is the middle, 0.71-ish, and root 3 over 2 is the largest, 0.87. What that'll let us do is figure out which of the x values need to be the largest in certain positions, which of the y values need to be the largest or smallest in certain positions. Let me show you what I mean. So if we focus in on this first quadrant here, just focusing on the x values for now, this is 0 to 1, so we're going from smallest to largest. So if you plot these x values that we care about on the unit circle, 1/2, root 2 over 2, root 3 over 2, go from smallest to largest. And what that means is if we're looking at these angles here, we know the smallest x value, so we're just focusing on x again, will be from the axis to the pi over 3, right? That's the smallest distance. This is the medium distance, this is the largest distance. So the smallest distance will be 1/2, and that's your x value or your cosine value. Medium distance, pi over 4, that's your root 2 over 2 for your cosine value. And then the largest distance to pi over 6, the x value or cosine would be root 3 over 2. And then similarly, we can do the same thing on the y-axis, right? We're going from 0 to 1, so smallest to largest. So the largest distance from the x-axis up to pi over 3, that would be our largest y value, medium y value, smallest. The largest is root 3 over 2. The medium, root 2 over 2, and the smallest is 1/2. So that's a quick way you can just, if you know which one's largest and which one's smallest, you can figure out where these values go and in their positions for x's or y's based on how far away they should be from the x or y axes. So let's put this all together and just do a quick example. Let's say you are asked to find cosine of 7 pi over 6. You don't know what the answer is, and you're not sure where 7 pi over 6 is. The first thing to do is figure out where is that angle. It's a pi over 6, so we should be able to count by pi over 6's until we get to 7 pi over 6. So starting at 0, we're going to count 1 pi over 6, 2 pi over 6, 3 pi over 6. We're not counting this, by the way, because it's a pi over 4. So 1, 2, 3 pi over 6, 4 pi over 6, 5, 6, 7 pi over 6 is right about here. Let's put a dot there. So 7 pi over 6-ish. Now this angle down here is pretty much the same as this angle, which is pretty much the same as this angle over here. Right? So we know something about that angle over there in our first quadrant. We know that at that point, which is pi over 6, the cosine value is root 3 over 2. We know that because this is the furthest distance in the x direction, right? You have to go all the way over here to the largest x value, right? This one's medium, this one's the smallest. So all the way over here, which is the largest x value, which is root 3 over 2. And then the y value that goes with it would be 1/2, because for the y value, when you're over here, this is the smallest y value, right? The smallest y value, medium y value, largest y value. So you know it has to be 1/2. Now over here and over here, these are going to be the same values, just different signs. And what are x and y in terms of their signs over here? Well, it's the negative x direction, and it's also the negative y direction. So negative for x, negative for y. That tells us that our points over here are going to be negative root 3 over 2 and negative 1/2. Right, so we don't have to construct any of the other pieces of the unit circle. We just have to find what they call the reference angle, which is the angle in the first quadrant. We have to figure that out, which was our pi over 6, and then we have to figure out what the values are there, and then just figure out the signs at our actual angle. So cosine of 7 pi over 6 in this case should be negative root 3 over 2. That's our answer. Okay, so hopefully this helps you understand where the values on the unit circle come from and how to quickly come up with this without having to rely on tables or memorization or getting decimals in your calculator and figuring out what the decimals are equal to, like root 3 over 2 or whatever. Let me know if you have any questions, and thanks for watching.